When I am done with you, I am going to kill everyone else.
Big ass beatdown coming up!
Oh, hey there. It's another Troesch quiz review. Here are the topics. Graph the sine function y is equal to 3 sine of 2x plus 3 over 1 period. Label the amplitude, period, and key points on the graph. So, what you got to know to do this problem is first, you have to know what the original sine of x function looks like. How can you graph a sine of x function without knowing how the original thing looks like? What you got to know is that the original function starts at the middle point. So when I'm talking about key points on the graph, I'm talking about either the maximum point, the middle point, or the lowest point. If I have the original graph of sine of x, it's always going to be a middle point. If I make the amplitude 3, it's always going to be, right? It's still, no matter what I do, it's still going to be a middle point. Now, in later lessons, you have to learn about what horizontal shift is, basically moving this function left or right, and then that's when things can change, right? If I put a minus 2 in here, then that, then it's not a middle point when it crosses the y-axis. But I don't think you need to know that for the quiz. For the quiz, you got to know that basically the sine function, it just starts at the middle point when it crosses the y-axis. All right, so when it hits the y-axis, it's going to cross the middle point. Cosine function starts at a maximum point. So unlike the sine function that starts at the middle point and then it goes to a maximum point, a cosine function starts at a maximum point and then goes lower. So it goes a maximum point when it crosses the y-axis, then it goes down, up, down, up. All right, go back to the nice sine of x problem, right? So we know that it starts at a middle point and then it goes up to the maximum point, right, for a sine function. If you put a negative sign in the front, it's just going to flip it. So it's going to go from the middle point to now the minimum point. Same thing for the cosine function. It starts at the maximum point and then it hits the middle point. If I put a negative sign here, now it starts from the minimum point and then it goes to the middle point. All right, so in order to kind of do these problems, you got to understand what sine of x, you got to understand the original graphs for sine of x, cosine of x, and their negative counterparts, okay? Or another thing to know about these problems in general is you need to know how to find the period of the graph. So what the period represents is just how long does it take for this function to complete one cycle. So in this case, right, how long does it take for this function to complete one cycle? So it's going to represent this length right over here, right? This is one cycle, right? So it's going to be this length right over here. And for y, for the original function, y is equal to sine of x, the period is going to be equal to 2 pi. Okay? Now, notice how the distance is. Now, take a look at this. Notice how in one period for my function, notice how there's 4. Now, take a look at this. Notice how in one period, notice how in one period for my function, notice how there's 5 sections. So you have this section, 1 section, 2 sections, 3 sections, and 4 sections, right? 1, 2, 3, 4, right? So notice how in one period, there's going to be 4 sections from one critical point to the next critical point. And if I wanted to find out the distance of one section, well, the thing is I have 4 sections. And if I know the whole thing is 2 pi, what I'm going to do is I'm going to take my 2 pi and divide it by 4 because there's 4 sections in one period. And that's going to give me pi over 2. And this tells me the length of basically the distance from one critical point to the next critical point. So this distance right over here is pi over 2, right? This distance is pi over 2. So this point is going to be located at pi, right? Because pi over 2 plus pi over 2 gives me pi. The distance from these 2 points is also pi over 2. So this point right over here is going to be located at pi plus pi over 2, which is just 3 pi over 2. And then finally, the distance between this point right over here and this point right over here is also going to be pi over 2, right? So pi over 2 plus 3 pi over 2 gives me 2 pi. All right, so the key thing to know is that if you're trying to find out the distance from one critical point to the next critical point, what you do is you find out the distance of the whole thing, which is your period. And what you're going to do is you're going to divide it by 4 because there's 4 sections in total. Okay? Right. Now, in order for me to graph out the sine function, I need to know 4 things. I need to know my maximum point. So what is the maximum value that this function can take on? I need to know the minimum value, and I need to know the middle value, and I need to know the distance from one critical point to the next. So, it's just the same thing I discussed here, right? I need to know what this distance is to get kind of my scale for my x-axis. So how do we do this? Now, how do you find out the max point for a sine function? Notice how if I have a function like sine of x, y is equal to sine of x, right? Notice how if I add a 3 to the end of this function, it's going to move my maximum point up by 3, right? Originally, for y is equal to sine of x, my maximum point is equal to 1, right? My maximum point is equal to 1. However, if I move my function, if I add this plus 3 at the end, which moves my function up by 3 units, well, if I'm moving everything up by 3 units, well, my maximum point's also getting moved up by 3 units, right? So it's just going to be 1 plus 3, which in this case is 4. All right, I have a sine function, right? Sine of x. Let's just say we have y is equal to sine of x, right? And it looks something like this. Well, you can think about this as y is equal to 1 times sine of x. The number in front of the sine of x represents our amplitude. What the amplitude is the distance from our midline. So it's literally just the line in the middle, right? So if let's say my highest point is 1, and then my lowest point is -1, well, then the line in the middle of 1 and -1 is just going to be 0, right? So this one right over here just represents the distance from our midline to our maximum point, or it can represent our midline, the distance from our midline to the minimum point. Notice how the distance from 0 to 1 is 1, and the distance from -1 to 0 is also 1. All right, now going back to our example, what is our midline for this function? Well, our highest point is 4, our lowest point is 2. So the line in the middle is going to be y is equal to 3. This represents our midline. Now, what happens when I make our amplitude 3? What happens when I make our amplitude 3? Well, notice here how the distance from our midline to the highest point is now 3, right? So in this case, now my highest point is just going to be my amplitude plus my midline, right? So this number at the end represents our midline, okay? So if I wanted to find out the maximum point of my function, what I do is I take my amplitude and I add it to my midline. All right? And this kind of makes sense here, right? Because what happens is this tells us our midline, right? And then this tells us our amplitude. So how much is the distance away from the midline, right? So if I add these two values together, I'm just going to get the highest point. In this case, right? Look at this. Our highest point is going to be 6 at 6, right? So if I have 3 sine of 2x plus 3, what I just do is I just take my last term and I add it to my first term, right? So 3 plus 3 is going to give me 6, which represents my maximum, right? Well, how do you find out the minimum point? Well, in order to find out the minimum point, what you do is in order to find out the minimum point, what you do is you take your last term and you subtract it by your amplitude. All right? Because think about it, right? Our midline for this function is right over here, right? This is our midline. We said how that's y is equal to 3. Now, if my amplitude is 3, well, we know that the amplitude represents the distance from the minimum point to the midline. So in order to find out this minimum point, what I do is I take the y value for my midline and I subtract it by how much it's going down, which represents my amplitude, right? So if I take the value of my midline, right, and then I subtract it by how much it's going down, aka my amplitude, right, because our amplitude represents this distance right over here, well, then I'm just going to get the minimum point itself, right? And you can see how this works here, right? 3 minus 3 gives me 0, which represents my minimum point, right? So my minimum point right over here is 0. And so just to clarify things, let me just highlight this. So let's call this term right over here A. Let's call the inside term right over here B, and let's call the last term D. So my maximum point is just going to be adding these two terms together. So A plus D is going to give me my maximum term. In order to find out the middle term, I just look at the last term. So I just look at D. D represents my middle point. That's going to give me my midline, or the middle points, right? And then finally, if I wanted to find out the minimum point, I take my midline and I subtract it by my amplitude. So make sure you kind of remember this, but also you kind of understand it, right? Because if I move up, make sure you memorize this, but make sure that you also understand where these ideas come from. We only have one more thing to find out. We need to find out the distance from one critical point to the next critical point. So how do I do this? Well, notice how in order to find out the distance from one critical point to the next critical point, we said how we use this formula, right? We take the period of our function and we divide it by 4. But how do we find out the period of our function? And that's where our b term comes into play. So what we do is we take 2 pi and we divide it by the absolute value of our b term. And that's going to be equal to our period. And then once we get our period, then we can divide it by 4 to get our distance from one critical point to the next. So let's do this. So in this case, we have our b terms equal to 2. So 2 pi divided by 2 is going to leave me with pi as my period. So then the distance from one critical point to the next critical point is just going to be our period, which in this case is pi, divided by 4. All right. And now that we have all this stuff, let's get graphing. So we know that, remember, a sine function goes from the middle point, then it goes to the maximum, then down, down, up, right? It follows this trend. So let me just do that. So it goes from the middle point, which we said that's equal to 3, right? And then it goes to the maximum point, which we said it was 6. And then it goes down again. Then it goes down to the minimum point. And then finally it goes up again. And this should look something like this. And then for our x-axis, what we do is we just use our pi over 4, right? So this point right over here is just going to be pi over 4. The distance from this critical point to this critical point is also going to be pi over 4. So pi over 4 plus pi over 4 gives me 2 pi over 4, right? Now, if this distance right over here is also pi over 4, well, 2 pi over 4 plus pi over 4 gives me 3 pi over 4. Right, so I just want to make this clear, but look, so if we're going pi over 4 here, we're going another pi over 4 here, we're going another pi over 4 here, and then we're going another pi over 4 here, right? And then, so then this coordinate right over here would just be pi over 4 plus pi over 4, which is 2 pi over 4, right? And just keep adding pi over 4, right? Because that's the distance from one critical point to the next critical point. So then this point right over here would just be 3 pi over 4 plus this pi over 4, which is just 4 pi over 4. And you can simplify things if you want. 2 pi over 4 is just pi over 2. 4 pi over 4 is just pi. But I like to, write this all out because, for you guys, because then you can clearly see the trend that's going on, right? So yeah, this is basically how you graph it. This is how you graph it, right? You just have to find out all of these 4 things using these formulas, but make sure to understand where these formulas come from. All right, graph the sine function y is equal to 2 cosine 3x plus 5 over 1 period. All right, let's do this problem. So first, let's label out my things. So this 2 at the front, all right, is going to represent our a value. So our a value is going to be equal to 2. Whenever you're dealing with amplitude, it's always going to be positive. So we're going to ignore this negative sign right over here. All right, so only focus on this positive value. Our b term is going to be equal to 3, and our d term is going to be equal to 5. So our maximum point is just going to be a plus d, so 2 plus 5 is going to be 7. Our middle point is just going to be d itself, so it's just going to be equal to 5. And our minimum point is just going to be equal to d minus a, so 5 minus 2 is just 3. Now, the final thing we need to know is the distance from one critical point to the next critical point. So in this case, I need to know what the period is equal to, right? In order to find out critical points, right, critical point distance, I need to know what the period is equal to. And we said how our period, the formula for it is just going to be 2 pi divided by the absolute value of b. So 2 pi divided by 3 gives me the period. And if I want to find out the critical point distance, I'll take the period and I divide it by 4. So this divided by 4 is the same thing as this multiplied by 1/2 using fraction properties, right, keep, change, flip, and we get pi over 6. Now, one last step before graphing it. How does this function look like? What is the general shape of this cosine function? Well, we know that a regular cosine function, when it hits the y-axis, it's a maximum point, right? However, notice how we have a negative cosine function. And we said how what the negative cosine does is, what it does is it makes this function makes the function hit the y-axis at a minimum point. So we're going to start off at a minimum point, then we're going to go to a maximum point, then down, and then you know the drill. So our minimum point, right? We start at a minimum point. So let me do it in a more vibrant color. So we're going to start out at our minimum point, which we said is 3. So it's not going to be down there. I don't know why I drew that. It's going to be at 3. Then we're going to go to the middle point. Then we're going to go to the maximum point. And then we're going to go back down. All right. So this is how the function sort of looks like. I mean, I could have drawn it better. So let me just do a little quick adjustment. But you kind of see, how to do these types of problems, right? After you found out all of this information, you just need to know how the function looks generally, right? So in this case, is it a negative cosine function? Is it a negative sine function? Is it a regular sine function? Is it a regular cosine function? So you need to be able to identify how, these general functions look like. And, finally, we're just going to use our critical point distance. So for our x-axis, so this point right over here is just going to be pi over 6, right? Because right over here, that's our critical point distance. So that means that this point right over here, this top point, is going to be 2 pi over 6. This point is going to be 3 pi over 6. This point right over here is just going to be 4 pi over 6. And we're done. I mean, for the last problem, I was a little too lazy to do it, but label the amplitude, period, and key points on the graph. Well, our amplitude is just going to be, we know our midline, right? Our midline is at y is equal to 5. So our midline is going to be here, which means that our amplitude is going to be the distance from the midline to the highest point, which in this case is 2, and that matches up with this 2 right over here, right? And it also asks you for the period of our graph, so it's just going to be this distance right over here. This is when the function completes one cycle, right? This is one cycle. Let's say if we have this sinusoidal function where our maximum point is at y is equal to 7, our middle point is at y is equal to 4.5, and our minimum point is at y is equal to 2. And let's say that the distance from one critical point to the next critical point is 2. What is the equation of this function? Well, the thing you got to know is, first of all, notice how our function passes through the y-axis at the middle point, and then it goes to a minimum point, meaning that this represents a negative sine function. Remember, when you have a normal sine function, it looks something like this, where it passes through the middle point and then a maximum point. So a negative sine function would pass through the middle point and then the minimum point. So in this case, this represents a negative sine function. All right. Now, sine functions, for this quiz, you only got to know this form for a sine function. So sine functions can be written in the form y is equal to a sine of bx plus d, where a represents the amplitude, b represents 2 pi divided by the period. So b represents 2 pi divided by the period, and d represents our midline. So in this case, what is my amplitude? Well, we said how the amplitude is represented by the distance from the maximum point to the middle point, or to the midline, right? And my midline in this case, so for my problem right over here, my midline is going to be at 4.5, right? Because we said how our middle point lies at 4.5, right? So this is going to be our middle point, our midline, all right? And our midline is represented by the d term. So that's what we're going to put at the end, okay? So midline is represented by the d term, okay? Now our amplitude, remember, this is the distance from the midline to the highest point. So what's the distance from 4.5 to 7? Well, that's going to be 2.5, right? So in this case, let me just erase this real quick. So in this case, so far what we have is we have y. So far what we have, oh my God. So far what we have is y is equal to negative 2.5 sine negative 2.5 sine plus sine of whatever's in here plus 4.5. Now, inside the parentheses, we're always going to have x, right? Notice this form for a sinusoidal function. Inside our parentheses is always x. Now, how do I find out this b term? Well, in order to find out the b term, well, we need 2 pi. We take 2 pi and we divide it by the period of our function. And remember, the period just represents the distance it takes for this function to complete one cycle. So how long does it take for this function to complete one cycle? Well, notice how there's 4 parts to it, right? Right, this right over here represents the distance from one critical point to the next critical point. All right. But notice how, remember, we said how there's 4 sections in one period, right? We said how in a period, this is going to be equal to, but remember, I said that, remember, I said how in order to find out the distance from one critical point to the next critical point, what you do is you take the entire period and you divide it by 4. And this is the distance. This gives you the distance between critical points, right? Distance between critical points. Right, so if I take my whole period and I divide it by 4, because there's 4 sections, that's going to give me the distance between one critical point to the next critical point. Well, if I'm given the distance of the critical points, but I'm not given the period, well, to find the period, I would just multiply both sides by 4. I would just multiply both sides of the equation by 4. And I get that the period is equal to 4 times the distance between the critical points. So in this case, my period is going to be equal to the distance from one critical point to the other, which is equal to 2, right? Because this point right over here lies at x is equal to 0. This point lies at x is equal to 2, right? So the distance from 0 to 2 is 2. And 2 times 4, right? It's 2, which is here, times 4 is going to be equal to 8. And that's going to represent our period. Another way to think about this is this length right over here. This length right over here is 1/4 of a period. All right, because notice how there's 4 sections to a period, right? 1, 2, 3, 4. And this simply just represents 1/4 of the entire thing. So if you multiply the 2 by 4, you just get 8. All right, now we said how our b term is equal to 2 pi divided by the period. So 2 pi divided by 8 gives me pi over 4. And we are done. That is the answer to our problem. And just for good measure, if you have a graphing calculator, you can check the answer. It's 2.5 sine of pi over 4x, and this is going to be plus 4.5. All right, let's see if our answer is correct. Okay, so we know that it hits at x is equal to 0, it hits 4.5. Let's see if this is correct. Okay, this is a good first start. We know that at x is equal to 2, our y value is equal to 2. So x is equal to 2, y value is equal to 2. And it looks like my maximum point is 7. And, well, so is the case here. And, well, everything looks pretty good. So, this is the answer. A boat in the ocean rises and falls with the waves in a sinusoidal pattern. The height of the boat above the sea level varies between 3 feet at its lowest point, so 3 represents our minimum value, and 15 feet at its highest point, so 15 is our maximum value. One complete cycle of rising and falling takes 8 seconds. So if it's talking about one complete cycle, well, we know that one cycle represents the period, right? So 8 seconds. So let me just write this down. So you know how in a sine function, right, or a cosine function, the distance when, this function completes one cycle, this is represented as the period, right? This one, how long does it take for this function to complete one cycle? Well, in this case, it takes 8 seconds for the function to complete one cycle. So our period is going to be 8, in this case, 8 seconds. Write a sine equation that models the height, h of t, of the boat above sea level as a function of time. All right, let's just translate what that means. So as a function of time just means that as time increases, so time is on the x-axis, so as time increases, our height of the boat is going to change. So whenever it's talking about a function of blank, well, on our x-axis is going to be that blank, and our y-axis is going to be the thing that's affecting, which in this case is the height, right, of the boat. T of 0 corresponds to the boat at its average height. The critical point after that is a maximum value. Okay, how do we do this? So I'm going to be graphing this function out, and going to be writing an equation for it. Just, so you guys get some extra practice. Now, first of all, what I'm going to do is I'm just going to erase the negative x-axis. So I'm just going to erase all of this. Because the thing about time is it can't be negative, right? So I can't have negative time, right? So I can't have like -1, -2 seconds, right? So I'm just going to erase all of the negative x-axis. I'm just going to leave the positive one. Okay. Now, we said how T of 0 corresponds to the boat at its average height. The average height represents basically the middle point or the midline, right? Think about it. You take your highest value, you take your lowest value. If you take the average between these two values, you get the average height, right? You get the thing in the middle, right? So the average of these two values, the average between the highest and the lowest point, gives me, in this case, 9, which represents my average height. So 9 is our average height, which in this case is in feet, right? This is in feet. So 9, let me just label this here. So our average height is at 9. Now we know that the critical point after that is a maximum value. So whatever value we have after this is a maximum value, which means that our equation for our function is going to start out with y is equal to sine of blank. All right, we know it's going to be a positive sine function. The reason for this is because, well, we know how sine functions, first of all, they go through the middle point, and then they go through the highest point. Well, take a look at what we have here. Middle point when it crosses, or when it touches the y-axis, and then a highest point. And we said how the highest point is 15, so let me just write that down. And we also know that our minimum point is at 3, so let's also write that down. Okay. Now, we know that one complete cycle of rising and falling takes 8 seconds. Okay. So that means that the distance from one critical point to the next critical point is just going to be 8 divided by 4, which in this case is 2. So this x value right here is 2, and we can label our x-axis like this. So it's going to be 2, 4, 6, and then 8. Because remember, right, when one period of our graph, we have 4 sections, right? If I just draw this out for you guys, right? So this is going to be at 4, 9. This is going to be at our minimum point here is going to be at 6, 3. And then once again, our middle point is going to be at 8, 9. But notice how, remember, in one period, there's going to be 4 sections, right? Now, if I wanted to find out the distance of one section, what I do is I take the whole thing and I divide it by the amount of sections there are. So in this case, our period, remember, our period divided by 4 gives us the distance between 2 critical points, right, that are adjacent to each other. So this is how you graph the function. I mean, in this direction, our function will go on forever. So I'm just going to denote this with an arrow mark, just to show y'all. But yeah, that's basically how you graph this function. Now, if I wanted to write out the equation of it, remember, sine functions are y is equal to a sine of bx plus d, where d represents our midline. So in this case, our midline is 9, right? Our line in the middle, or our average height. There's a lot of names for it. So, don't get confused by it, okay? The d just represents the midline, all right, or the average height. Our a term represents the amplitude. So in this case, it's going to be the distance from our midline, which in this case is 9, right? It's going to be the distance from our midline to the highest point. The distance from 9 to 15, in this case, is 6. So that's going to be what we're going to put in front of our sine. And I mean, there's still an x inside here. But what about our b term? Well, remember, our b term is 2 pi divided by our period. So in this case, we know our period is 8. So 2 pi divided by 8 is pi over 4. And that's going to be the equation for our sinusoidal function. And we graphed it as well. Just to show you guys. So we have our answer is y equal to 6 sine of pi over 4x plus 9. Look at this. Right? We hit our x-axis at 0, 9. Then highest point is this. Then we go back to the middle. Then we go back to our middle, then down, and then back up. And notice how the distance from one period, right? The distance of one period is 8, which is what we said right over here, right? 8 seconds. So this is correct. Solve for sine of x, given cosine of x is equal to 3 over 5, x is in quadrant 4. So in case you don't know how to do these problems, well, first I'm going to do the proof of the Pythagorean trig identity, and then I'll teach y'all how to do this. Basically, when you create an angle on a unit circle, so this is the unit circle, it has a radius of 1, and it is centered at the origin. Now, when you create an angle on it, so this right over here is our angle on the unit circle, right? Now you have to draw a ray to create this angle, right? You have to draw a ray to create this angle. Now, this ray is going to intersect the unit circle at some point. Let's just label this point x comma y. All right. Now, what we're going to do is we're going to draw an altitude down from that point. All right. So now notice we have this right triangle. Now, let me ask you. So you can all agree that this length right over here represents the x value of this point, right? This point right over here has x value of this length, right? This part of our triangle represents our x value. Now, this part of our triangle represents the y value, right? So let's do some trig. Now, remember, this is the unit circle, and it has a radius of 1. Now, notice how this represents the radius of my circle. So this length is going to be 1. So the hypotenuse of my triangle is going to be equal to the radius of my circle, right? Which is equal to 1. Now, cosine of this angle that we created, well, we know cosine is equal to adjacent over hypotenuse. So cosine is going to be equal to x over 1, which is equal to x. Sine of theta is going to be equal to opposite over hypotenuse. So sine of theta is going to be equal to y over 1, or just y. Notice how I can substitute this in for my coordinate. So it turns out that if I pick any point from the unit circle, the coordinate of that point is going to be equal to our x value, which we said is our cosine value. It's going to be equal to cosine of theta, comma, sine of theta. Right? X comma y. Right? Same thing. So if we know the x value is cosine of theta and the y value is sine of theta, right? Notice how this is a right triangle, right? I said this probably like 2 times, but remember, this is a right triangle, right? So we can do the Pythagorean theorem. We can say that cosine squared theta, or a lot of people, they might write it like this, cosine theta squared, if they're new to this. But, this is the same thing. Cosine squared theta, this is the same thing as cosine theta squared, okay? These two things are the same thing, but it's like simpler to write it out this way. So I'm just going to write it out this way. So cosine squared theta plus sine squared theta. So aka cosine squared plus sine squared gives me my hypotenuse squared, or 1 squared. And this is the Pythagorean trig identity. It's just derived from the Pythagorean theorem, okay? Now, we're said solve for sine of x, given cosine of x is equal to 3 over 5 and x is equal to quadrant 4. So remember, you have 4 quadrants, right? This is quadrant 1, this is quadrant 2, this is quadrant 3, and then this is quadrant 4. Okay? This is 1, 2, 3, 4. It's always counterclockwise. Now, when it says x is in quadrant 4, basically all that's saying is that the angle that I've created, is in the 4th quadrant. So all that's saying is our angle is in the 4th quadrant. Okay? Now, we can use this formula to solve it, right? So we're given that cosine of x is 3 over 5. 3 over 5. So we can substitute this into our equation. So 3 over 5 squared plus sine squared theta is equal to 1 squared. And then, so this is 9 over 16 plus sine squared is equal to 1 squared. 1 squared is just equal to 1, so let me just write that down. If I subtract 9 over 16 from both sides, I just get 7 over 16 is equal to sine squared theta. And if I just square root both sides, I just get sine of theta is equal to plus or minus the square root of 7 over 16. I can rewrite this as the square root of 7 over the square root of 16. So this is just going to be equal to the square root of 7 over 4, right? Because the square root of 16 is equal to 4. Now, how do we find out? So we get sine of theta is equal to plus or minus the square root of 7 over 4. But the thing is, we know that the angle that we created is in the fourth quadrant, right? And in the fourth quadrant, right? So let me just highlight this. So if I draw the unit circle again, right? If I draw my unit circle again, notice how this point right over here, right? We can represent this as cosine of theta, comma, sine of theta, right? Where sine of theta basically represents the y value of this point. And notice how the y value for this point in quadrant 4 is negative, right? No matter which point on the unit circle I pick, notice how in quadrant 4, our y value is always going to be negative. So in this case, our answer is actually just going to be negative square root of 7 over 4. We're going to ignore the positive answer because sine of theta is always negative in quadrant 4. So the important key takeaways is you got to memorize this formula. And, this is just derived from the Pythagorean theorem. And you have to memorize that, if you create an angle in the first quadrant, well, notice how your x value and your y value is going to be positive. So it's going to be double positive. If you create an angle in the second quadrant, notice how your x value is negative, right? Your x value is going to be negative, but your y value stays positive. If you're in quadrant 3, so you create an angle like this, right? Notice how both your x and your y values are negative. And finally, in quadrant 4, remember your x value is positive, but your y value is negative. So if you remember these two key takeaways, you got this. Find the 15th term of this sequence. 3, 7, 11, 15. Notice how to get from one term to the next term, you have to add 4. So every term right over here, right, you have to constantly add 4. And let's say this sequence goes on forever. And let's say if we're trying to find the 15th term of this sequence. So how can we do that? In order to find out a specific term of a sequence, this is going to be equal to the first term plus n minus 1 times the common difference, where n represents the term you're on, so the term you're basically trying to find, right? And d represents the common difference. So in this case, if we're trying to find the 15th term, this is going to be equal to the first term, which is 3, plus, in this case, 15 minus 1, right? You can think about this as the location of our term, and it's going to be multiplied by our common difference. Our common difference is this 4 that we've discussed, right? It's the number we have to constantly add to get to the next term. So 15 minus 1, and this is going to be times 4, and then, so it's going to be equal to 59. And that's our answer. The first term of an arithmetic sequence is 2, and the common difference is 5. Write an explicit formula for this sequence. So whenever it's talking about an explicit formula for an arithmetic sequence, it's just saying, can you write this sequence in this form, where it's a sub n equals to a sub 1 plus n minus 1 times d. So in this case, we know that the first term is equal to 2. So this is what I'm going to do. So I'm going to write a sub n. This is going to be equal to our first term, which we know is 2, plus n minus 1 times the common difference, which is 5. And that's just going to be the explicit form, okay? So whenever you're writing the things in the explicit form, right, questions like these, just ask yourself, can I simplify this equation any further, right? This problem right over here is giving me the first term, which I can substitute in here. This problem is giving me 5, which I can substitute for my common difference. So it's just a matter of substituting in the terms you know. Find the sum of the first 10 terms. Okay, so if you're trying to find the sum of an arithmetic sequence, the sum is just going to be equal to the average between the first term and the last term multiplied by the amount of terms there are. So in this case, I'm trying to find out the sum of the first 10 terms, right? So that's what I'm trying to find out. So the sum of the first 10 terms is going to be equal to the first term plus the 10th term, right? So everywhere we see n, notice everywhere we see n, we replace it with a 10, right? So it's going to be a sub 1 plus a sub 10 divided by 2, right? It's going to be the average between the first and the last term multiplied by the amount of terms there are. In this case, there's 10 terms, right? We know the first term is equal to 4. But how do we find out what the 10th term is for this sequence? Well, to find out the 10th term, we can use this formula, right? We can use the formula we just discussed. To find out a specific term of a sequence, it's going to be equal to the first term plus n minus 1 times the common difference. So in this case, it's just going to be the first term plus, in this case, 10 minus 1 times the common difference, which is, the common difference in this case is 6, right? Because you have to add 6 to get to 10, then to 16, right? 22. So I'm going to have 6 times 9 plus 6, evaluate out to be 58. So the 10th term is going to be equal to 58. So we're going to substitute that in here, and we should get the answer. So 4 plus 58, so 4 plus 58 gives me 62, divided by 2, that's going to give me 31. 31 times 10 is going to be 310, and that is going to be our answer. So it's going to be equal to 310. Find the 8th term of a geometric sequence. So notice, instead of arithmetic sequences, we have a geometric sequence. A geometric sequence is a sequence of numbers where instead of adding, right, in an arithmetic sequence, you constantly have to add a common difference. But for a geometric sequence, you're constantly multiplying. So in this case, we're constantly multiplying by 2 to get to the next term. Now, if you want to find out a specific term for a geometric sequence, so all the arithmetic stuff I did is in the white kind of color. I'll do the geometric stuff in yellow. So to find out the specific term for a geometric sequence, well, it's going to be equal to the first term times our common ratio, which is just represented by, the number that we're constantly multiplying, right, to get to the next term. And it's raised to the power of n minus 1. So if I'm trying to find the 8th term, this is going to be equal to the first term, which we know is 5, times the common ratio, which we know is 2, to the, in this case, 8 minus 1. So 2 to the 7th is equal to 128 times 5 is 640. And that's going to be our answer. Find the sum of the first 8 terms of the geometric, so the sum of the first 8 terms of a geometric sequence, where the first term is 5 and the common ratio is 3. So if you want to find the sum for a geometric sequence, right, before, this was a sum for an arithmetic sequence, right? This was a sum for an arithmetic sequence. But the sum for a geometric sequence is going to be the first term times 1 minus r to the n. So 1 minus the common ratio to the kind of the location of the terms, the amount of terms there are, right? Divided by 1 minus r. So in this case, if I'm trying to find out the sum of the first 8 terms, this is going to be equal to the first term, which we know is 5, times 1 minus my common ratio, right? And then it's going to be to the nth power. So in this case, to the 8th power, right? Notice these two things match up. Divided by 1 minus 3, right? 1 minus my common ratio. So 3 to the 8th power. So it's going to be 1 minus 3 to the 8th power. And then this is going to be divided by negative 2 times 5. 1,600. Okay, 16. So it's going to be 16,400. And that's going to be our answer. The first term of a geometric sequence is 6, and the common ratio is 1/2. Write out a recursive formula for this sequence. So the recursive formula is just a formula for, it could be an arithmetic sequence, it can be a geometric sequence, it can be neither, but it's a sequence that's written in terms of a sub n minus 1. So it's a sequence written in terms of the previous term. So let me show you what I mean. So the first term, the first thing we got to do for a recursive formula, we always have to write out what our first term is equal to. So our first term is equal to 6, right? Now, the next step you're going to do is you're going to write this a sub n, and then you're going to write this equal sign, and you're just going to put this a sub n minus 1. Now, a sub n minus 1 represents the previous term to a sub n. Right? For example, if I have a sub 8, well, then the term before a sub 8 is just going to be a sub 8 minus 1, right? Or a sub 7. Now, to help y'all visualize this, let me just kind of write out the sequence. So our first term is 6, and we know our common ratio is 1/2. So what I'm going to do is I'm going to multiply 6 by 1/2 to get to my next term. So it's going to be 3, then it's going to be 1.5, then it's going to be 0.75, and so on. Notice how in order to get from one term to the next term, well, what I have to do is I have to multiply by 1/2. So to get from my previous term to the next term, what I do is I take my previous term and I multiply it by 1/2. And that's going to be the recursive formula for this sequence. So notice how it's written in terms of the previous term, right? What do we have to do to the previous term to get it to the next term? We have to multiply it by 1/2.